Hello all, welcome back. We're just getting ready for the final thematic session of the Spatial Data Science Symposium. So thank you all for sticking around. All right, well, I will pass it over to you then, Victoria, and take it away.
Okay, great. So happy to have everyone here. Thanks so much for joining us. We are here to talk about spatial data insights into urban accessibility. And so we have a really great lineup here, some great organizers. This session really emerged because to build truly inclusive societies, we need to leverage spatial data science to uncover and address hidden accessibility barriers. And so this session was really dedicated to exploring innovative spatial data techniques and mapping projects that are reshaping our understanding of urban accessibility. Today, you'll hear from researchers all across the globe, and we seem to be going from the west to the east. But before we start that, I want to give a big congratulations to the two new doctors in our group who will be presenting with us. We have Dr. Milias and Dr. Teeuwen, who will be presenting their PhD research as well. So yeah, congrats to all of them. But I am lucky and happy to be able to kick off this session talking about mapping our cities for all and community accessibility mapping and trends across industries. And so this project really emerged because accessibility barriers in our cities often hide in plain sight, yet they limit the freedom and the opportunities of countless individuals every day. In Canada, we know very little about these barriers and lack the data we need to effectively map, model, and understand accessibility barriers. To bring these accessibility or these hidden obstacles to light and fill in the data gap, University of Calgary and AccessNow spearheaded Canada's largest coordinated accessibility mapping initiative. And that was called MOCA, Mapping Our Cities for All. And so the result made headlines around the globe, and the results were resounding that our cities are not accessible, our buildings are not accessible. It was even picked up by news outlets like the Financial Post. So interesting to see this geographic mapping project being projected around the globe and people actually caring about urban accessibility. And so many of the talks at SDSS, many of the great talks so far at SDSS have been on the cutting edge of technology and a lot, not surprisingly, on the recent advancements in LLMs and GeoAI. But for this talk, I want to dial it down and dial up the community. In order to complete this study, we mobilized nearly 40 mappers across the country, many of them living with disabilities, to survey over 14,000 buildings. This community mapping initiative speaking of community mapping, whatever happened to VGI anyways, volunteer geographic information? If you're wondering about what the progress in kind of this research area is, I just published a progress report which tracks the rise, fragmentation, and future of volunteer geographic information. So check that out if you're interested in that. We partnered with AccessNow. AccessNow is a company that it's a social enterprise that started in Toronto, but it's worldwide, and their goal is to map the accessibility of buildings across the world. They already have a robust global crowdsourced platform that facilitates the mapping of these buildings. And as you map them, you can indicate an overall accessibility score. So you can indicate something as accessible, partially accessible, or not accessible at all. And these are user ratings. And then adding to those user ratings, we can add that rating, but also take photos, select tags, and describe their experience using this map. And so what was interesting for us in partnering with AccessNow for this research project is that we wanted to take their platform that crowdsources the accessibility of buildings and kind of apply a more robust scientific framework in order to determine what a representative sample of buildings would be. And so a key part of that is having targeted data creation rather than just letting the community map wherever they wanted to map. We created study sites, and then we worked to determine what would be a representative samples of buildings. This project was originated by Accessible Standards Canada, and they wanted to learn more about the accessibility of the buildings, but we wanted to create a representative sample. When we work with census data, in Canada anyways, we have a long form census that is randomly selected, and they give the long form census to about 25% of the population, and they use that as a proxy for the whole population. And so we thought we had to map 100, if we could map 100% of the buildings within a dissemination area, then we would have more comparable results. So that's where we started. We determined this representative sample. We picked dissemination areas to map in our study sites, and then we calculated the dominant accessibility levels and then assessed the patterns of business accessibility. We did this across 20 different study sites. The study sites included Vancouver, Calgary, and Ottawa. And then we also picked 17 non-cities, so 17 municipalities that include towns, villages, and hamlets that are located in central and southern Alberta to get a better sense of kind of non-large city accessibility as well. And so we map by dissemination area. In Canada, the dissemination areas are a census unit that cover the entire country. And so our results is that we ended up collecting over 130,000 data points and mapped over 14,000 new businesses. We hired 40 mappers, and this is an interesting kind of add to the crowdsource model where we actually hired people. So is it actually crowdsourcing or volunteer geographic information? It's kind of maybe a hybrid of that and a more authoritative study. Got a lot of images and got a lot of tags. And then our goal from that data was to understand the overall accessibility rating in these areas. And so we mapped it by accessible, partially, and not accessible. Ottawa had the highest level of buildings rated as fully accessible. When we initially started this project, we engaged the mayors to see if we could have a little friendly competition. But when the results came out, none of them wanted to advertise that they, even the mayor of Ottawa didn't want to advertise that they had the highest rating at 50-something% accessibility. And then interestingly, what was important to us was to understand the spatial distribution and the patterns across the country of these levels of accessibility. And so in this case, we used advanced spatial analysis to identify hotspots that are of inaccessibility that permeate our cities. And then, so by looking at these maps, we can see the widespread nature of accessibility barriers and buildings that are accessible and not accessible. A lot of urban sites, especially older ones, perform poorly in terms of the accessibility of buildings. In the downtown core, we really start to see this kind of checkerboard of areas that are kind of a mix of accessible, partially, and not accessible. And so that's the dominant accessibility rating across the major cities in this map. And then this map shows the dominant accessibility rating of the rural municipalities or non-city municipalities. And so out of these 17 municipalities, 9 had the majority of locations mapped were considered accessible, and 7 are partially, and there was only 1 that actually was dominated by non-accessible buildings. Then the next thing we wanted to do was just determine patterns using spatial analysis. So what can we see about these buildings across the country? The first one is we looked at hotspots to test the degree of inaccessibility and compare it to other locations. And again, we see concentrated in the downtown core that we do have hotspots that have higher levels of inaccessibility in the downtowns compared to some of the other spots. We also applied local indicators of spatial association just to confirm the results of the hotspot analysis. And again, we see that concentration in the downtown cores of buildings that are not fully accessible. And then, of course, we have to measure that pattern and measure and test how strong that pattern is. And so we applied spatial autocorrelation using the global Moran's eye. And we can see that, that these patterns actually show positive spatial correlation and that they're statistically significant, and that there are cluster patterns, or that we see that the accessible buildings are actually clustered together, and as well as most of the not accessible buildings are clustered together. So this measure is basically saying where there's an accessible building, there's more likely to be accessible buildings around it, and where there are inaccessible buildings, there's more likely to be inaccessible buildings around it. And then we took these results and decided to see if we could map them across industry trends. So we determined trends across, we matched the data with North American industry classification data to see what the trends are across the industries and if we could detect patterns in that emerged there. We're still working on this, and we actually have more data from AccessNow beyond just the MOCA project to analyze this. But what really stands out here, if you can see this, is educational services have the highest rated, or the highest proportion of buildings rated as non-accessible. And all of us living and working and spending a lot of time at universities recognize how important it is to make our campuses more accessible, but also realize some of the barriers that still exist. And so I think the conclusion is there's a long way to go to make our cities and societies more accessible, and a lot we can do for that. And that spatial data, I think, has a really important role in understanding the accessibility trends across these businesses and knowing where to target for improvements. And so you're able to find the full report at accessnow.com/MOCA. We're in the process of turning this into an academic research paper, because this is currently was a report to the federal government, and we did not think it was going to have nearly as much impact as it did, and we're so happy it did. If you're interested in this research and this type of research, we also put out a call for papers in Canadian geographies about spatial approaches, methods, and technologies for inclusive cities and societies. And here we're really keen to get at these projects that are really community driven, focused on inclusion, and in some cases even really emphasizing the small n of this research. You know, we're moving in the direction of big data and analytics, but I want to remember community mapping is important, engaging the people is important, and hearing their perspectives is an important component of a more accessible society. And with that, that is the end of my presentation. Just want to give a big thanks to my research assistant, Marsh-Ann, a Master's of GIS student who helped create some really great visualizations. So that's all for me. Thanks, everyone. And happy to turn it over to Shiloh now for her presentation.
Can you see me?
Absolutely.
Here I am. Okay, thank you so much. So today I am presenting something that is very related to what Victoria has been talking about. I am going to discuss ethical implications around GeoAI on the example of curb ramp classifications in Seattle, which is a key piece of accessible infrastructure. As geographers, I think we are uniquely positioned to both engage with and use the tools of AI while also drawing from geographic foundations in representation and visualization. So in this presentation, considering AI as a learning collaborator in research, I ask if data and AI can speak, then what do they say and what are the implications of peeking into the black box of complex algorithms for how we approach research? I conclude by tentatively proposing that we add relevance to conversations about reproducibility and replicability. This work builds on previous analyses of missing data and outliers. It is a work in progress, and I look forward to your feedback. My thinking is grounded in disability theory and critical sociological work on data and AI from authors like Kate Crawford and Bowker and Starr. As Crawford writes, the affordances of the tools become the horizon of truth, and classifications are technologies that produce and limit ways of knowing, and they are built into the logics of AI. I also draw from May-Po Kwan's work on algorithmic geographies. It is unquestionable that big data has shifted how we do geography, and especially GIS and spatial data science. But also, big data must be algorithmically mediated, and research results may be as much an artifact of the algorithm as the data. In this presentation, I explore how data and algorithms drive the horizon of what can be known in spatial data science. The goal of this research, as I said, was to classify curb ramp locations in an urban area to facilitate safe route planning for people with disability, especially wheelchair users. Conceptualization, operationalization, and measurement are vital aspects of research design. Traditionally, researchers first articulate shared meanings of abstract concepts, conceptualization. We then look for variables in the world to capture those definitions, operationalization, and then attach data to the variables, measurement. As the example illustrates, this is a narrowing process. In practice, though, the path from conceptualization to operationalization to measurement is often flipped in quantitative studies. Available data and the formats they are in, as well as the constraints of the algorithm used, determine how abstract concepts are conceptualized. Quantitatively speaking, this is unproblematic. A study inherently shaped by available data and algorithms can still be both replicable and reproducible. A reproducible study is one in which a researcher can duplicate the results using the same data and materials. If you were in the last session, you learned all about that. A replicable study is one in which a researcher can duplicate the results with the same procedures, but new data. The question I propose we add to conversations of replicability and reliability is relevance. That is, what is the practical or social applicability? A relevant outcome of this research would need to keep in mind what a curb ramp does and the goal of safe travel for people with disabilities. Curb ramps vary greatly in practice. Here you see a selection of curb ramp images from New York, Mexico City, Spokane, Washington, and St. Louis. Despite this variety, I can generally identify a curb ramp in space. I am sure most of you can as well. The pertinent question then is how to translate this into data that a machine can read, learn from, and begin classifying with. This image shows the imperfect way that I did that translation with open data. I trained my model using Seattle's open curb ramp data, which, as is common, represents curb ramps as points. I used these points to label a polygon. My data sources were all open, meaning free and downloadable by anyone. LiDAR point clouds provided elevation of ground points. I also used the location of streets, intersections, and landmarks, as well as color bands from aerial imagery. These pieces of information were fed into a random forest regression model. I used the random forest regression model because it performed better in this case than something more complex like the point CNN, and because of its simplicity. I can better see what and how a random forest model is learning. A further challenge in machine learning methods is that most prefer balanced data, despite the fact that most of what is interesting for research is rare or unbalanced. I ran a number of models with balanced and unbalanced data over 2 iterations. I did not train on the unbalanced data and validate on the balanced data because that is not a replicable test in a case where nothing is known about the area to classify. In the second iteration, I filtered the validation points based on the agreed upon result of models 2 and 5, which had a very low number of false negatives. That means that they didn't identify a curb ramp where it was present. I used the same blend of balanced and unbalanced data for training in the last 4 models. I then mapped the models according to replicability, relevance, and accuracy in the graph on the right. Models 6 and 3, for example, are not highly replicable or relevant because they were validated based on a data set on knowing information about curb ramp locations. Models 8 and 9 were not very accurate and thus not very relevant. The best performing model, according to all 3 considerations, is Model 10, which exhibited higher accuracy, is replicable, and thus provides a semi-relevant result. Recall that curb ramps were rare among points. A model could achieve high accuracy with unbalanced data by classifying every point as not a ramp. That is what you see with models 1 and 4, which were trained on unbalanced data. As I mentioned, models 2 and 5 had a very low number of false negatives, and you see a sort of donut pattern in the labeling of ramp points, mostly surrounding intersections. Again, here in the second iteration, the 2 models trained on unbalanced data labeled most points as non-ramp. These also achieved a high level of accuracy due to the rarity of ramp points. The 2 models trained on balanced data, 7 and 10, show a result that begins to approximate the true shape of a curb ramp. You can see that here. In the top left is the location in Google Street View. Below that shows the area classified as a ramp by models 7 and 10, that's in black. The original point location from the open data and the hexagonal representation for training. On the right is the aerial image and the results of models 7 and 10 overlaid together. This is a bit of a strange case because there appears to be only a ramp on the one side. However, the entire area exhibits many of the characteristics of a curb ramp, especially based on the information fed into the models for training: aerial imagery, distance from streets and intersections, and elevation. Similar results are shown here. Locations A and B exhibit the exact same pattern I just showed. Area C is obviously not a pedestrian curb ramp to my eye. However, it does share characteristics of a pedestrian curb ramp in as far as it is a way of traveling smoothly from sidewalk to street. Similar to the location C in the last slide, here are 3 locations where pedestrian curb ramps were not present. Location A and B show something useful, which is a break in the labeling of curb ramp where a car would pass. This is relevant for safety. So returning to the interaction between data, AI, and study design, available data and the way they were cartographically represented shaped these results at every step. Consider that in part this study begins with something that can be measured. Curb ramp locations, which are not point features, were formatted or represented as such in the open data. I then labeled training data using hexagon areas to capture more ramp points. This is also an inexact representation. The variables that were available to train the model to identify curb ramps were not exhaustive, but came to define the feature curb ramp through modeling. The model learned that a curb ramp is typically concrete, near an intersection or near a street, and has a slight elevation change. This is important information, but it is not what I meant by pedestrian curb ramp in the beginning. Even a curb ramp, literally concrete, can exhibit a wide range of characteristics, making it harder for AI models to identify. In the critical AI or AI bias literature, there are numerous examples of negative impacts which may be sourced to researchers trying to have AI do something too complex. A few other examples of concepts too complex for AI are crime or terrorism, spheres of affect and emotion, and even higher ability. To this challenge, I would suggest that those of us using AI simplify the concepts that we are trying to identify. Perhaps in this study, instead of claiming that I am identifying curb ramps, I am actually identifying locations where concrete sidewalk has a change in slope to the road. Identifying these locations is not irrelevant if it filters the research space to a more manageable size for ground truthing or other data collection or verification processes, as Victoria covered. Finally, I will acknowledge that with better data and more advanced methods, I may have identified curb ramps with greater precision and accuracy. I don't disagree. However, I do believe that challenges related to missing data and outliers will continue to befuddle AI no matter how complex the model. To illustrate, I'll share a little story from Jetta Treviranus about her experience tinkering with models for autonomous vehicles. I wanted to see what these models would decide if they encountered some of my friends and colleagues who do things unexpectedly. I brought a capture of a friend of mine that propels herself backward in her wheelchair. When I presented a capture of my friend to the learning models, they all chose to run her over. I was told that the models were immature models that were not yet smart enough to recognize people in wheelchairs. They would expose them to learning data that included many people using wheelchairs in intersections. When I came back to test out the smarter models, they ran her over with greater confidence. In line with this example, I would argue that more data and more complex models may reduce error, but they will not eliminate it. And I believe that geographers occupy an important place in seeking to identify where the error is using classic understandings of the computational challenges in spatial data science, including representation and visualization. Relatedly and for fun, I'll leave us with a provocation from a short story by Stanislaw Lem. In this story, Truel's Electronic Bard, an inventor wishes to program a computer to write poetry, only to realize that the program found in the head of an average poet, after all, was written by the poet's civilization, and that civilization was in turn programmed by the civilization that preceded it, and so on to the very dawn of time, when those bits of information that concerned the poet-to-be were still swirling about in the primordial chaos of the cosmic deep. Hence, in order to program a poetry machine, one would first have to repeat the entire universe from the beginning, or at least a good piece of it. Thank you, and I look forward to your thoughts and questions on this work in progress.
That was great. Thank you so much, Shilo. Beautiful presentation in addition to interesting.
Oh, thank you.
I am so happy to turn it over now to Dr. Milias to share more of his research around accessibility.
So, hello everyone. First of all, thank you so much for acknowledging our PhDs with Roos. We both graduated a month ago from TU Delft. We did our PhD in the Urban Analytics Lab, supervised by Achilleas, who is also the director of the lab. Roos will be the next speaker. And I'm very excited today to talk to you about two of the tools that I developed during my PhD, which basically came into life out of a need to somehow communicate my research to a broader audience. So on the one hand, we had the academic research papers that were there with new methods on how to measure pedestrian accessibility and related factors. And then we decided to try to develop something that could potentially bridge a bit academia and industry. So we developed these tools. I will very briefly go through them. I don't have much time to go into many details, but I love discussing about them. So feel free to reach me either in the Q&A or even later. But I want to somehow show you a bit this kind of steps that we took and the result that we had in terms of an open access, publicly available kind of tool. So starting with the CTwalk map, our idea there was that my research is focused on pedestrian accessibility. And what I wanted to see is to what degree can we somehow measure and highlight those destinations in the urban environment that promote different individuals and different demographic groups to encounter each other. So I was thinking that if we all walk, for example, would that bring more segregation or less? Do our cities have those kind of spaces that they're accessible to different people when they walk, and they can then promote them to encounter each other? So first of all, the data sources that we used to study that, they're both open access, so everyone has access to them. You can download the whole database yourself as well. The one comes from the Central Bureau of Statistics. It's a Netherlands-based dataset and includes population data on a resolution of 100 to 100 square meters. So they tell you basically where people live in those 100 to 100 in this grid, and their demographics, how many people are from different demographics like age groups, ethnicity groups, income groups, etc. So it's quite detailed. And I also used the OpenStreetMap, which you probably all know, to collect from there different kind of destinations like parks, playgrounds, public squares, basically places where people could meet each other, and also the street network where people can walk. So based on this data, we followed the following three steps. So first of all, we took the walkable street network from OpenStreetMap, meaning streets that are tagged as streets for pedestrians, not highways. And I'm emphasizing that because walkable is a bit of a vague word. We transformed it, we represented it as a graph, and then we used this graph with a layer on top of the households to measure from each household where people can walk within 5 or 15 minutes. So we measured the 5 or 15-minute walks from each household. The second step is that we first measured accessibility, pedestrian accessibility, in the sense of what is the total number of destinations that people from each of those households can reach within a 5 or a 15-minute walk. Then we also separated some categories of destinations to see how many of those are public spaces, cultural places, etc., etc. And we also saw how equitable those kind of destinations are distributed along different cities in the Netherlands. So we could also study the differences on accessibility. And now the third step is that we used a measure of co-accessibility, meaning that we wanted to study how mutually accessible a destination is from different demographic groups. On this one, we focused on age groups. So first, we calculated the total number of people who have access to each destination. Then we separated these kind of numbers per age group to see which groups are more accessible by children, which by adults, which by elderly. And then we also calculated the age diversity of each of those destinations. So basically, how age diverse is the set of people who have access to each destination within a 5 or a 15-minute walk. Basically to see which are those destinations that promote intergenerational encounters, that we have a mix there that somehow promotes the different age groups to encounter each other. So this is a short video of CTwalk. First, you can see basically how the street network shapes the 5-minute walk set based on when you live, or the 15-minute walk set. And this is a nice example also to understand what does a 5-minute city or a 15-minute city mean, and how this is shaped from the street network or the canals or the kind of physical barriers there. Then we have the layer of accessibility. So we can see the inequities in urban accessibility, how many places you can access within a 5 or 15-minute walk based on when you live. So here we have 191 places when in the center of Amsterdam. And then we go to a different area on that it's further from the center, and we see like a very different image there. And then we can also dive in, see the actual points of interest, the actual places that exist there. So to see what is accessible. And if we click on a place, we can also see who has access to this place. So the co-accessibility of these places. And we can see that in terms of a number of children, adults, or elderly. We could also have done it with different kind of demographic groups as well. The data is there, and the methodology would be similar. And then we can compare those. So this is the CTwalk. And then something that was missing, basically, is that maybe you have already thought about it, is that we considered access, pedestrian accessibility, only in terms of distance and time, basically. What is accessible within a 5-minute walk or a 15-minute walk. And of course, there are way more factors that could affect what promotes you to work or discourages you from working. So we saw that this problem and we said, okay, let's do something about that as well. And we decided to develop a walkability index. So an index that could tell us which streets promote people to walk and which discourage people to walk. And while there are many different walkability indices there, what we realized is that each city has its own kind of particularities. So we decided to try to do that on a city-specific way. So focus on Amsterdam and see what people say that affects them walk in Amsterdam, and not try to do a global kind of solution that might not work for every city. So we did this also in 3 steps. The first step is that we collected factors from the literature. So we studied walkability-related literature and some specific to the Dutch kind of context. We took those factors, and then we found urban planners and designers who work and live in Amsterdam. So they had the context, and we asked them to prioritize this kind of factors based on their own experience, based on their professional experience. So we use this kind of approach, which is called Q methodology, which is a very interesting way to collect qualitative data and then convert them to quantitative data and scores. So ultimately, we had scores on how important each factor of those is on walkability. And on the third step, after we also interviewed them, and we saw that there are some factors that could be represented by the same theme, some factors for a different theme. And we could cluster those factors together. And when we also saw which factors we can find from existing open data sources again. So again, we only used open data, this time even more tailored to Amsterdam, because we have a lot of data there. We developed CTstreets. So this is similar logic with the previous map in terms of UI. On the first level, we can see the different walkability scores from 0 to 100 per neighborhood. So those are administrative neighborhoods of Amsterdam. And we can compare how different those are from one neighborhood to the other. When we use the different themes, we can also see how the picture changes based on what factors are we most interested in. And eventually, we thought that it's more interesting to study those different themes separately than in an overall walkability score, because it's very hard to understand what's happening in the overall walkability score. If you dive now a bit deeper on the map, we can see the same information, but now on a 5 and 15-minute walkable area. So how walkable is the 5 and 15-minute area around each household? So we could see the same information, but on a different kind of resolution. And if we dive even deeper into the map, we can also see the same information on a street level. And to be precise, on a street segment level. So for different street segments, we could see the score as well. And to be as transparent as possible, when you select a specific theme of walkability, so for instance, landscape, we also have the information on what do we mean with the 8.8 score. So we mean 0 amenities with open fronts, 0 public benches, etc., etc. And of course, people are allowed to disagree with that, on what degree those factors mean landscape. But this is what we received from the urban planners. This is what they told us, and this is what we could map on this map. It has, of course, its limitations. So this is it. It's not the full story, but hopefully it's a trigger for you. If you want to learn more, we have those maps that exist online. You can find them. We also have documentation pages online that are written in a very simple words, and you can see more or less how we built it. And we also have the academic papers that, if you're interested, explain the whole story behind those and the methods we used. And I'm always very, very willing to have more discussion about that. Now we also run some experiments on those. So if you want to be part of those, please let me know. And now The last thing that we realized when we did the CTstreets is that we did do a city-based kind of measure, right? It's specific to a city, but still, maybe you noticed already, when we talk about pedestrians, we don't really check who is the pedestrian, which demographic group are we representing now when we're talking about walkability. So I will leave my colleague Roos now to tell you how she actually dealt with this problem, focusing on children.
Yes, well, thank you, Vasileios. My name is Roos. I'm also a recent PhD graduate at Delft University of Technology. And indeed, so I'm going to shift now the focus from places that are accessible to multiple demographic groups. I'm going to shift the focus towards what happens when you really focus on one group. So in this case, it's children and their access to urban green space. So on the next slide, I'm asking Vasileios to proceed them for me. When we talk about green space, what I mean is all urban space covered by vegetation of any kind. So usually these are parks or urban forests, sometimes very small pocket parks in the city. And I'm focusing on a particular age group. It is children aged 6 to 11 years old. So in this kind of primary school age, where children start to gain some independence from their parents, but it's still very limited. Well, why do we care about children's access to urban green space? That is because it helps them to be physically active, to interact with each other socially. It also helps to combat stress, obesity, to improve their attention at school. But we see that children in this particular age group, they have a much lower autonomy compared to adults, to us. Also, parents will set restrictions, and they're to a certain extent dependent on their parents to accompany them to green space. So why we care about measuring it, that is mostly for very large-scale health studies where we try to understand better mechanisms between children's access to urban green space and the health and cognitive outcomes in children. So how they socialize with each other, how green space helps them to be more mentally healthy. It also helps to allow cities to map how equitable access to urban green space is spread over the city, if there are certain populations that do not have the same possibilities as others, or to benchmark progress over time when interventions have happened. But what we see is that the measures that are used are often not tailored to the case of children. So they do not incorporate the particular restrictions or barriers that children face. Or when they do, they are really limited to one neighborhood and they cannot scale to entire cities or multiple skills. So what we did is we tried to develop new ways to measure children's access to urban green space that do apply across urban skills. So every street segment within a city, so basically on similar maps as Vasileios just showed, and also that can be applied to multiple cities. In this case, we focused on European cities, but the idea could also generalize to cities worldwide. Then the first question that we ask ourselves is if we want to create measures that incorporate the factors that affect children's access, which are those factors? That was not entirely mapped out, so that is what we did in this conceptual model. We put down all the factors that affect children's access, and you see that they go well beyond just proximity or homes or school locations. But they also incorporate barriers that children face, the traffic, that is a main limiting factor, how easy it is to go to the green space via certain routes. Well, I will not go over the entire model, but there is a lot in there also, the beliefs and values that parents hold, for instance, the intentions that families have to visit green space and how well that suits how well the green space suits the intentions and the motivations that people have to visit it. So this is a very complex overview of factors that matter, and we tried to zoom in on some of them and to see how we could incorporate those into our measures. I will present two new ways to measure. The first one is all about passing through green space on the way between home and school. And the second one is about visiting green spaces without adult supervision. So for the first one, what we did is we created this model that is, this is an example from Amsterdam. So you see all the streets in Amsterdam, and we created some sort of a heat map based on where children's homes and children's schools are located, to somehow estimate how likely each street segment is to be crossed by children, because the assumption is that if children do not need to undertake a separate dedicated trip to green space, but instead they already pass by a green space, they pass through it, they are much more likely to stop after school times, for instance, to play a bit in the green space with their parents or with peers from school, opposed to when they really need to undertake a separate trip on the Sunday afternoon, so to say. So this really helps to map the routine exposure of children to green spaces. When we zoom in, we see that this is kind of how the model works. So we overlay the heat map of children with the green spaces in the city, and then we can see that, for instance, this green space is also crossed. So if you hit enter, that it is crossed from one side to the other as well. And it's not only a destination that can be reached from either the west or the east side. So we see that especially small size and really well embedded green spaces that are connected to the network are accessible to children that pass through them, opposed to green spaces that are much wider or near other open space that are much harder to pass through on a daily basis. Then there is a second model or measure that we developed that is to measure children's access to urban green space without adults that accompany them. In this case, we did not start from the data or from the model, but we started by talking again to people. So in this case, we put maps and a lot of pictures of urban spaces on the table, and we discussed with a range of health and urban environment experts what are the barriers to children in these places to access green space, what promotes them to access those green spaces, and to somehow translate those factors to physical indicators in the urban environment and the data that we have about them, so the spatial data, the map data. On the next slide, you see an example of what the outcome of this measure looked like. So this is an example from Utrecht in the Netherlands, where we see that we kind of calculate the zones of the city that have access to small parks or to playgrounds, while incorporating the fact that children cannot cross every road, that traffic might be too much for them to cross the roads without adult assistance. So, for instance, on the top right, you see a crossing that is just off limits for children in this age range of 6 to 11 years old, while on the bottom, you see this nice pedestrian bridge that allows children to cross barriers independently. Also very interesting to me was that on the left side, you see on the top one green space that was deemed very accessible to children because it is very open, very well embedded in that neighborhood, while the bottom one, to me personally as an adult, it looks very attractive. But our participants said that for children in this age range, it is there is not enough social control. It is a bit too big, too natural. It's hard to see children from a distance. So it's less suited for children to visit without adult supervision. So these are the kinds of things that we now incorporate into our measure. Well, to wrap up, in my research in general, we also found that sometimes qualities that make a space a green space conflict a bit with what makes a space well accessible. So it was very interesting to me to realize that there's a certain balance between how accessible a place is in the city and how natural or green it is. I think this is very good to keep in mind that we need to optimize for the right things in a city. And finally, on the final slide, yes, I think it's very important to keep in mind that we need to use multiple measures in parallel, because we can tailor one measure for children without adults, another one for this home to school traffic, but I think they all have their value in their own particular way. So it's very important to use them in parallel, and finally to also complement in the end the data-driven measures that we have with community knowledge and fieldwork, because in the end those are very valuable additions as well. So yes, as Vasileios, I'm also always happy to continue the conversation. On the final slide, we have all of our contact information, so both from Vasileios and me, and from the director of our Urban Analytics Lab in Delft. So please reach out to us if you have anything to discuss.
That is brilliant research from all of you. Great to have some new doctors and some new fresh research to share with this as well. Thanks so much for sharing that, Roos and Vasileios. Okay, moving on. Dr. Blake Walker, over to you.
Great, thank you. And thanks to everyone for the opportunity to share some of what's going on in our little research group here at the Friedrich-Alexander-Universität, FAU in Erlangen-Nurnberg in southern Germany in Bavaria. My name is Blake Walker. I'm Associate Professor for Digital Cultural Geography here at the FAU. And what I want to share today, rather than sort of excerpts or summaries of a single project, is rather some of the discussions and debates and, that we've been having in my research group, which is a collection of eccentric individuals with a whole variety of experiences and abilities and disabilities. And a lot of what we've discussed in our group is what I'd like to sort of throw into the ring as food for thought. And in our more recent discussions over the last couple of years, we've turned our focus towards questions about green space and health, and particularly the ways in which green space is being communicated and modeled and measured, particularly with geodata, not exclusively, and being touted as this sort of cure-all, silver bullet for whatever ails you. And this work is largely drawing on critical perspectives on the romanticism of wilderness as a pure healing object that we can dip into, gain benefit from, and sort of pop back out. A lot of this work draws a bit on the concept of nature or green space as social construction in many ways. And I really love this particular quote of thinking about purity and the misanthropic normative dichotomies, the ways in which nature, green space serve one function as being places for gathering, places for well-being, places for recovery, right? But at the same time are strongly contested spaces. And we're thinking about ways to represent those tensions a bit more in our geodata and in our analyses. So that's what I want to show today. This is deeply rooted in Sarah Watmore's nature culture, a fairly well-established set of perspectives on the roles of green space and nature in health and well-being. And what I'd like to highlight here is the tension between thinking of urban green space on the one hand as a sort of this dangerous other, this risk space, the space of inclusion and exclusion, and on the other hand, contrasting that with nature and green space as being this sort of holistic healing space as well. And I think there's a lot of interesting tensions there that we can pull apart, particularly in the way that we relate to actually modeling this stuff, right? So I want to draw on three key critiques that are really within my working group. That's our motivation behind what we're doing in the last couple of years here. And one of these is a bit of a concern about some of the dominant classist envisionings, the ways in which green spaces are envisioned, imagined, constructed, and used as being largely, in many cases, ableist, classist, and often exclusionary in that sense. And so we want to turn our attention, as has been mentioned in previous presentations in this session, to who is being represented and who is not being represented in these envisionings. And I think an important aspect of this is the sort of other body reductionism, which I'm going to talk about a little bit later. The simplest version of this is looking at non-visible disability and how this is simply going, in many cases, entirely unrepresented in these types of studies, and thinking about the plurality of experiences of these spaces, and how that is not simply a single form of I go to the park and meditate, I recharge my aura, and then I'm back out again. But there are many different ways in which many different people use these spaces. And so we're thinking about ways to really represent these different types of phenomenological approaches as well. So a lot of what I'm showing today is from this particular project called Resilience Through Cultural Landscapes Amidst Climate Change, funded by the Bavarian State Ministry for Health and the Bavarian State Ministry for Environment and Consumer Protection, right? And we wanted to grab onto this particular term in German is Kulturlandschaft. It's cultural landscape if you translate it one-to-one, but it's really much more than that. And I'll explain why here in a second. We think of cultural landscapes or Kulturlandschaften as built social and natural environments all together in the way in which they're experienced. It cannot exist, right? It's the tree that falls in the forest but doesn't make a sound. In fact, we can take something like an historical building or a square or a statue. We could take an agricultural barley fields in the middle of basically nowhere, right? So in the rural areas, or a remote alpine lake, and understand those all as cultural landscapes, because the important denominator here is that they're experienced places. And we can think of those as also being phenomenologically holistic. It's not just about what you see, feel, or touch. It's what you hear, it's whom you're with, it's what you're doing in the space, right? It's really thinking about the landscape and attaching the term culture not to indicate the arts or whatever in particular aspects, but rather the broader set of human experiences that we enjoy in these spaces, or in many cases do not enjoy. And so I want to just quickly highlight that this Kulturlandschaft concept is important because it's both created and constructed by persons, by humans, right? It's deeply subjective, they're deeply contested, and they're socio-political almost by definition. And so this is kind of the framework when we're thinking about environments in terms of green space that we're moving through. And within the realm of this particular project, we're looking at the ways in which these cultural landscapes, these Kulturlandschaften, may promote or hinder resilience and well-being, particularly for persons with disability or persons living with particular vulnerabilities, by thinking a bit more broadly about health, in the sense that there is the physical benefits, there is the mental health benefits, but also that cultural landscapes provide spaces for society to exist, to grow. And we're also interested in the ways in which climate change may disrupt that or create opportunities for that. So this is sort of the framework in which we're operating, particularly with a focus on positive adaptive measures. What can we do to make these spaces more inclusive amidst the challenges of climate change? So now to the GIS stuff. The way we would typically begin this kind of work is just looking at what's available, what can we reach, right? Standard approach. Find your features, make buffers, right? For example, we might look at a straight line distance to particular features because of heat mitigation, for example, where the spatial function is in many cases fairly linear, not entirely true, but a good approximation. And we might use, for example, NDVI, remote sensed imagery, put a buffer around it and then see what happens, right? This is a very common classical approach. But I think we're well aware of what some of the shortcomings are of this approach, and we've seen in presentations already in this session that in many cases it's more appropriate to think about accessibility in the sense of physical accessibility and mobility, and what are the spaces that can be reached, what are the barriers to reaching those spaces. So a standard GIS-based approach would be a network analysis, and then we include barriers, for example, for persons using wheelchairs, right? And looking at ways in which we can map that, and we've been doing this in northern Bavaria around the city of Bamberg for 2 years now. But we wanted to get one step closer to the experience of it. And so we started thinking about how can we look at visibility. For example, my next door neighbors have a beautiful garden, wonderful trees, right? I get to enjoy those too, even though I may not hop over the fence and sunbathe in their backyard, but I still benefit from having visible exposure to those spaces in the visible sense. And there's a lot of research more recently that shows that visibility has actually a very significant impact or effect size on things like stress recovery or attention restoration. We might do that, or the way that we're doing that is by doing something called viewshed analysis. And I'll just explain briefly kind of what the people in my working group have been doing. And we can imagine an individual, a simulated individual, standing on a single pixel, any location within our urban landscape, and they can move across that landscape depending on the ways in which they're able to move, their particular mobility abilities, let's say. And there are certain segments of that landscape that may be visible or invisible. So in this particular example, our small gray person in the bottom left is unable to see part of the street because a fence is blocking it, but they are able to see the hedge across the street and the taller tree. The area directly behind the hedge is green but not visible. And so we're trying to think, how can we capture that and model that in a way that makes it useful for the kind of work we want to do? So in this particular instance, we simulate this individual for every pixel for a variety of simulated individuals for different characteristics across our entire study area. And then by using LiDAR imagery, 3D models, we're able to derive view sheds basically for the whole study area. We applied that using LiDAR imagery and high resolution NDVI imagery for the city of Vancouver, which is shown here. And you can see that the result is one in which we have red areas where there's basically no green to be seen, and then greener areas where if you're standing on any individual pixel, the value, or rather the color hue shown here, represents the percentage of green within your sort of view cone or your view sphere or dome, we might say. And so we've been able to apply this in anywhere that has high resolution LiDAR so far. Excuse me. Yeah, but we still come across the problem that these are really data deterministic types of models, right? Is we're really taking massive generalizations about our population that we're simulating, we're placing them in this sort of raster space, and performing a series of deterministic calculations. Please excuse me, it's a kindergarten cold. Okay, and we want to move that a little bit closer to the actual subject here in this particular case, thinking about the individuals represented in our models, not as individual units of analysis in the sense that they are a data object, but rather thinking about how we can actually get closer to human experience in this particular sense. So for example, something that we don't see in our models is the quote seen below is this particular place is perfect for socializing, exploring, and enjoying the local culture. Well, a green space approach, like I've just shown you, doesn't capture that. So how do we capture that? The way we capture that is we went ahead and did like what many people are doing these days, and we made an app. And using this particular app, persons with who self-identify as having or as living with disability or particular vulnerabilities are able to go and provide location-based multimedia data, whether it's videos, audio, tags, whatever. And we do follow-ups in which we go along with them. So we move through those spaces with them and talk about what they're doing. And then we also, for a small subgroup, do it digitally. So using Street View and using other visual imagery, for example, to move through this. And facilitated GIS play is really just working with them in the lab and playing with the data a little bit. It's been quite interesting to see what they came up with. I'm going to highlight a couple things here. One of them is really just how prominent, particularly our participants who are self-identify as living with a disability, whether it be a visible or non-visible disability, placed value on cultural landscape features that we would classify as deep urban gray, right? So for example, what doesn't show up in the classical green space approach and the way in which so much weight was placed on these, particularly for social and mental health. And based on our results from this, we've mapped them out, of course, with particular attention to individual data security and anonymity on a tool that is in development, but you can click through it if you want. It doesn't look great and it's all in German, but we've mapped out what this looks like according to a variety of climate prognosis models and attempting to try to map under different climate scenarios what features of the landscape and what spaces of the cultural landscape would be affected given scenario ABC, for example, right? And you're free to explore this if you want. The URLs in the bottom, or I can share it via email. I want to close with just sort of zooming back out to this, and I want to end with a little quote from Richard Rorty, an American philosopher who passed away several years ago. And he wrote something that I thought was quite interesting that I think can actually, in our group, in our discussions, has shaped the way in which we're actually thinking about how we use models and data. And that is that the process of coming to see other human beings as one of us, rather than as another, as them, is a matter of detailed description of what unfamiliar people are like and a redescription of what we ourselves are like. With this, I want to argue that we can reflexively and in working with these types of geodata and through a critical positionality, still be able to produce what I think are cool models, right? And do lots of great work with these incredible geodata sets. But at the same time, try to come closer to the lived experiences of persons who are living with disability or living with barriers to access. And that is broadly the thrust of what I wanted to share today. If you'd like to get in touch, I'm easy to find, and I would love to hear from you. Thank you very much for your time and attention. I appreciate it.
Great. Thanks so much, Blake. It's so interesting to, first of all, see these beautiful maps. Gosh, we should turn this into maybe a map gallery. But I completely understand your point about the kind of massive generalization and deterministic calculations. But what I find so interesting is kind of the layers of all of these, right? When we take the data I have on crowdsourcing the accessibility of buildings, and that Shiloh has on the infrastructure, and that you have on greenspace, as well as Roos and the walk score work as well. I mean, there's so much value in collaboration for this. So, you know, a question to the group is, how do we bring all this together? You know, how do we maybe, you know, have a better understanding of these phenomena we're studying collectively? That's to everybody too. I mean, we're here, I guess. That's one part of it, right?
I think we need a big grant.
Okay, big grant. Yeah, anybody else? Big grant's a good start. There's a lot of questions that were put in the chat here, but we quite literally have 2 more minutes. And so I don't think we're going to be able to really dig deep into any of these, but great to see the interest in this. And I think, you know, I do think there's a lot of potential to expand and develop this work. And something I was also thinking about as we were going through and seeing all the other amazing talks, is that I think there would be really great to have a database of resources emerging out of SDSS, because we've all shared kind of really cool published papers and apps and workshops and websites and all those things, that it would really be great to compile those, because I think there's a lot of collective intelligence from the work that we're doing together. Achilleas, too, you've joined us. Do you want to use our last minute to just share your thoughts on this research area?
Oh, wow. Thanks for giving the closing words. Thanks, Victoria. I think what's important here is that we see like the great variety that is happening, and now that we're identifying that, you know, when we're talking about accessibility and all these kind of things, that we really need to focus on like groups and separate groups, and that we need to go beyond, you know, these kind of generalized accessibility measures, but also to take a little bit of a distance from the individual ones, because there is a need to scale as well. So we need these kind of trade-offs, and we need to communicate those trade-offs very well when we communicate our metrics. So not only what is captured, but more importantly, what is not captured there, and be clear and honest about that. So I would say that this is like a kind of message that I get from this section, which I really enjoyed.
Great. Yeah, I entirely agree that we need kind of more personalized information, right? We need to recognize diverse mobilities in this. And with that, it is officially 12:30 in Calgary. And so I just want to close by thanking the organizers of SDSS. This is a community-led, community-driven conference, and this would not have been possible without the hard work of all of the really great people working behind the scenes. So thanks so much to all of you. Thanks to everybody for tuning in and listening. And that's the end of our session. So over to the closing session. Thanks, everyone.
Great. Well, thanks very much, Victoria, and thank you all for some fantastic work, really interesting stuff. And I think that's what makes SDSS so enjoyable, is seeing the wide range of work that people are doing. As you noted, there are a few questions in the Q&A. If you are all able to, if you would just mind, you can put a little response comment in there if you have some time just to respond in the chat. That would be really interesting, really helpful if you have that time as well.